there. My name is Olivia Florence, and I did my statistics final project on a data set about electric cars. Now that I've introduced myself, I would like to draw your attention to my slideshow. So I'm going to fix my camera angle here just a little bit. You won't see me, but you will see my statistics slideshow, and you will also hear my voice, so I hope that's okay. So as you can see, this is my my title card, and I've included a bunch of different car logos, and these aren't necessarily all cars that have been surveyed in my data set, but these are cars that sell electric cars or hybrid cars. So you might be asking yourself, why did she choose electric cars? Well, that's a great question. So I myself actually drive a hybrid car. It's a 2020 Honda Insight. It's actually this car right over here in the corner. I love it. It's the first car I've ever owned. I'm only 17 years old, so obviously I just got my license a couple months ago, and it's a really reliable car. It's also like super fuel efficient. I think the tank holds about 360 gallons, but I don't go through it very quickly, and I think that's attributed to like the half gas, half electric aspect of it. And also I chose to do my project on electric cars because, electric cars are better for the environment. When you're not burning gas and releasing, toxic fumes into the atmosphere, it's a lot better for the environment, and that's something that's really important to me. So my dataset observed quite a few aspects, if you will. This included the VIN numbers of the electric cars, the county of the state that the car is located in, the city of the state that the car is located in, the actual state that the car is located in. Most of the cars that were in this data set, there were, I think, over 150,000 cars or somewhere thereabout. Most of them were in Washington, but there were also some cars that were in New Jersey, California, New York, and other states. I'm gonna turn so I can look at it too. Also included the postal code of the car location, or the zip code. Included the model year. The cars ages like really varied, I guess. They're everything from like 1997 to this year, so quite a big range of cars, or I'm sorry, of ages of cars. Sorry, I'm a little nervous. We've also got the make of cars, which means like which brand made it, I guess. So you've got Chrysler, you've got Kia, you've got Tesla, Nissan, Chevy, and a few other cars. And then you've also got the model of the cars. So there was stuff like Chrysler Pacifica, the Kia EV6, the Tesla Model 3, the Nissan Leaf, the Chevy Bolt EV, and etc. etc. The data set also included the electric vehicle type, which was basically just whether it was a plug-in hybrid or whether it was a battery electric vehicle. Let's see, also included the electric range, which varied from 0 to 337 miles, I believe. Also included the base MSRP, which is something like the sales price. It really varied, but it was everything from like low prices to high prices. And when I say high prices, I mean roughly like more than 100K. Also included the legislative district of the car location, the DOL vehicle ID, the exact coordinates of the car, the electric utility company the car used, like G&E or like Tacoma, Washington Electric Company and whatnot, and also the 2020 census tract. So here are my descriptive statistics. This right over here is my histogram. This right over here is my scatter plot. And this right over here is my box plot. So obviously this isn't, oh yeah, also, I'm sorry, I forgot to mention this, but I would mostly survey the electric range category. So, which is what I did over here actually. I'm sorry. I used the electric range values. I'm so sorry. And this is the frequency, like how many times they occurred in the data set. I did something similar with the rest of the things too. Actually, over here in the scatter plot, I compared the electric range with the model year. And there was really no correlation between those two. And I compared the electric range down here for not my scatter plot, my box plot, sorry. Yeah. And I also did some hypothesis testing. Mostly I would do like, for my alternative hypothesis, like for example, like M1 was not equal to M2, or mean 1 was not equal to mean 2, or standard deviation 1 was not equal to standard deviation 2. And for most of the time, actually, for every single hypothesis test I ran, the p-value was always less than the significance level, so I ended up rejecting all of the hypotheses. And this is my regression graph. So basically what this graph means is that there was very little, if any, correlation between the electric range values and their z-scores. So yeah. And so overall, my conclusion is, electric cars are important. They're really good for the environment, and they can be just as amazing as a regular gas car. I know I had some biases against electric cars. In the past, I thought they couldn't go as fast as gas cars, or like they just like were funny looking, but that's actually not the case. Electric cars are just as great. Hybrid cars are just as great, and I hope you go out and purchase one, because there are, no matter what your budget is, there's always going to be some sort of electric car that is within your price range, or even a hybrid car would be great. Thank you so much for listening, and I hope you have a great holiday break.